Right, and so when we look at this example or this set of examples here, what we see is we still have equations of or functions of a quadratic type. Okay, here's 1 power, 1/2 is exactly double the other, because 1/4 times 2 is 2/4 or 1/2. So this still is an equation of quadratic type, but radicals aren't always expressed in terms of the square roots or the fourth roots. They might be expressed in terms of rational powers. So you have to be aware of that rational powers are radicals. Okay, and so when you solve a problem like this, we can still follow the same process. We let u equal our lesser power, so p to the 1/4, meaning u squared is going to be p to the 1/4 squared, which gives you 2/4 or 1/2. And that allows you to rewrite this as a u squared minus 7u plus 12 equals 0. Okay, and so if you solve this equation here, the two factors of positive 12 whose sum is -4, or -7 is -4 and -3. So we would have two values for u. U is 4 and u is 3. Okay, once you get to that point, you back substitute. U was p to the 1/4. So if we plug that in and solve each of these, here we take and undo the rational power. We take both sides to the power of 4, giving us p is equal to, now 4 to the 4th is not necessarily a common number, but if you multiplied it out, you get 256. Take both sides to the 4th here, leaving us p is equal to 3 to the 4th is like saying 3 squared squared. 3 squared is 9, 9 squared is 81. That one can be done mentally. Okay, and so you have these two possible numbers to choose from. Because we were dealing with rational powers, which are radicals, we do need to test and make sure these work in our original form. So if I took the square root, p to the 1/2 is the square root of 256. I get 16 minus 7 times the 4th root of 256, which we see right here is 4, plus 12. Does that equal 0? And you can see 16 plus 12 is 28, minus 28 does equal 0. So 256 checks. Do the same with 81. The square root of 81 is 9, minus 7 times the 4th root of 81 is 3, plus 12. Is it true that 9 plus 12 or 21 minus 21 does equal 0? Once again, yes, that checks. Okay, and so we have these two possible solutions here. Okay, I'm going to jump down to the bottom one, and then I'm going to have you try the middle one here in just a sec. But if we do the same process here on this last equation, we have quadratic type. Y to the 1/2 is double y to the 1/4. So we can let u equal the lesser one, y to the 1/4, meaning u squared will be y to the 1/2, giving us the new equation rewritten with u's as u squared plus 7u plus 10 equals 0. And the factors of 10 whose sum is plus 7 is plus 5 and plus 2. And so your two solutions here when you solve for u are -5 and -2, which means when you plug your y's back in, so y to the 1/4 equals -5 and y to the 1/4 equals -2. Now, before you actually go through and work through the math of this, the rest of this problem, realize what these rational powers mean. This means the 4th root of y. It's an even indexed radical. Can you take the 4th root of y and get a negative number? No. So that's going to be an extraneous solution anyway. If you multiply it through and come up with a value, it's not going to work when you plug it back in, and you can see that right here. Same here. The 4th root of y cannot equal a negative number. So these have two extraneous solutions, meaning that the answer does not exist. There is no solution. All right, I want you to try this middle one here on your own really quickly. See if you can come up with the solutions for that, please. So if we look at this example, same exact idea here. You have 1 power y to the 1/2 that's double the other, y to the 1/4. So we can let u be the lesser power, y to the 1/4, meaning u squared is y to the 1/2. When we rewrite it in that form, u squared minus u minus 2 equals 0. And so factoring this, we get the two factors of -2, whose sum is a -1, is -2 and +1, giving us u is 2 and u is -1. Okay, once we do that process, we can go in and back substitute our y to the 1/4 in for the u. So here we see the 4th root cannot equal a negative, so we're going to have an extraneous solution here. We can undo the process, take both sides to the power of 4, giving us y is equal to 2 to the 4th, which is 2 squared squared. 2 squared is 4, 4 squared is 16. And so that would be your one possible solution. We do need to check it and make sure it works. So the square root of 16, which is 4, minus the 4th root of 16, which is 2, minus another 2, does that equal 0? It does. And so our solution winds up being 16 for that.